morning, everyone. Welcome to our first CPD webinar for this year. If you have noticed, there is already a sign-in code. Please jot down the sign-in code now. And at the end of the seminar, we will also show the sign-out code. And then you will have to fill in the Google form from the link. Okay. My name is Ying. I will be the moderator of today. Most of my friends will know me as Zawa also. We are also broadcasting the seminar live on our PAM Northern Chapter Facebook page. Please share with your friends. However, those who watch this seminar via FB page, they will not be able to claim for CPD points. For those who have registered, as I mentioned just now, please jot down the sign in and sign out code later. So just a friendly reminder to all participants, please keep your mind muted to avoid any interruptions. We are very thankful today for Rockwool to sponsor today's webinar and presenting to us a rather technical topic, which is building design considerations on the hydrophobic characteristic and also the mineral wool insulation's hidden powers. In most situations, water spreads evenly when it hits the surface. Sometimes it beats into tiny droplets. While most of us have noticed the differences, a better understanding of these properties and its effect on building performance will be very beneficial to architects. Issues in building structures caused by water damage are very common in Malaysia, but this can and should be prevented. This presentation will zoom into the hydrophobic features of mineral wool insulation that naturally repel water. This session will be presented by Ms. Azanie from Rockwool. She is a technical engineer with more than 10 years of experience in the construction materials industry, specializing in safety and comfort. She holds a degree of electrical and electronic engineering from the University of Science, Malaysia, and uses her skill sets to provide technical solutions to both the general building as well as industrial segments. She is also a subject matter expert in testing, audit, and certification, and regularly provides knowledge sharing with both industry and academia in Malaysia, Indonesia, and Australia. We will have a Q&A session at the end of the webinar where you may raise your hands and unmute yourself to raise the question then. And should you have any questions throughout the seminar, you may also type them in the chat box for discussions later. So next, let us welcome our PAM Northern Chapter Chairman, Architect Liao Guang Chun, to deliver the opening remarks. Over to you, Chairman.
Hi, good morning. Good morning to everybody. I don't think I have much to say. I think Zawa already said most of the things already. And also in the advert, I think they already introduced everything about Rockwool. So anyway, I'll say good morning to all. And on behalf of PAM Northern Chapter, thank you for all for attending the webinar. And to our Muslim friends, Selamat Berpuasa. Thank you to Rockwool and especially Azanie for the presentation. And Garis for helping us to host the event. And our ever-efficient secretariat for organizing it, and not least Architect Chong Kok Chun for initiating it, and obviously Zawa for hosting, moderating the event. Okay, I think as I said, there's a lot of things about Rockwool I can say, but I think it's already been said in the advertising. Rockwool is a bit like Hoover to me. You know, when you talk about insulation, immediately it comes to mind it's Rockwool. You know, so whether it's other brand or whatever, we just say Rockwool. I think they have been kind of like the forefront in terms of battling climate change for many, many years already. Before climate change became not fashionable, you know, kind of up to date, trendy kind of thing. Rockwool has always been in there, and it's a hope that architects will participate in this particular practice and being proactive about it. I won't say much. I hope to learn more about hydrophobic insulation and its benefits in this seminar. Back to you, Zawa. Thank you very much. Thank you for attending again.
Okay. I think next we will pass to Ms. Azanie to start her presentation. Ms. Azanie.
Hello. Hold on. Let me just share the slide. Zawa, can you see the presentations?
Yes.
Okay, good.
we can.
Right, let me just mute it. Okay, all right. Okay, everyone, thank you actually for the introductions. For my topic, I'll talk about building design consideration, hydrophobic mineral wool insulation heating power. Well, this presentation will be divided into 3 sections. First, touch a little bit about Rockwool companies, and then we go for the second topics is to determine the performance of hydrophobic mineral wool insulation and how does moisture affect thermal conductivity. And lastly, I will talk about Rockwool Stonewool performance in regards to fire, thermal conductivities, covers under UBBL as well as Rockwool Stonewool. What are the contribution to the green building rating? So let's go straight to the first sections. Companies, okay, Rockwool is a company. It's a multinational company with 80 years of history. We have 51 manufacturing facilities with presence present in 120 plus countries. As a Rockwool company, we're not just producing stone wool for building and industrial applications. If you look at here in these round circles, we also actually use the application for flood mitigations, automobile industry, railway industry, a stone wool panel so durable that it can be applied for the external facade applications as well as urban horticulture industry through other Rockwool brand. In building applications, that's where we mostly apply here in South Asia. It can be used in various applications. So example here in roofing, we can do in metal roofs, single skin, double skins, flat roof, single ply member roof, concrete, or even metal decks, and even pitch roof. Okay, external can be ventilated facade, masonry cavity, EIFS, which is exterior insulation finishing systems. Internals, normally I think most of you will know, partitions, floorings, ductings, as well as concrete slab. We call it soffit insulations. But it's not just limited to this kind of applications. Any building system that actually require insulations, stone wool insulation can actually be fitted in. Let's say, for example, can also be used for passive fire protections. Let's talk about terminology, because this is where people may have, let's say, confusion in terms of the correct naming. When we mention actually mineral wool, it means fibrous material formed by spinning or drawing molten mineral. So it kind of like mineral wool is the parent, and then we divide it into different sections. So these different sections, depending also on what are the main ingredients. So we have stone wool, we have mineral wool, glass wool, ceramic fiber, as well as slag wool. Stone wool, definition by name itself, coming from basalt stones, dolomite stones, glass wool from the sand, limestone, recycled glass, ceramic fiber. It's also known as refractory materials, mostly used for very high temperature applications in industrial application, especially where the maximum service temperature around almost up to, like, say 1002 degrees C, primarily consists of aluminum silicate, which include fiber made from these polycrystalline fiber as well as molten glass. And slag wools, visually you cannot see any difference between stone wool and slag wool, but in terms of the ingredients component, it composes a higher percentage of slag, which is the blast furnace slag with some natural rock. So there are some of the performance that is different between stone wool as well as slag wool. Most of you familiar with the name Rockwool itself. Just to let you know, Rockwool actually is a trademark, it's a company name. Insulation, generically, what we would like to call it as stone wool insulation. So it kind of like, Colgate is like a brand name, but everyone rather say that Colgate, rather say that, let's say toothpaste. And it has been in our name for over 8 years, with trademark registration in over 60 countries globally. Okay, that's it for the introduction about the company. So let's go to the main topic, hydrophobic performance. Okay, the first slide, which is talk about moisture control in buildings. Why should we actually bother thinking about moisture control when we design a building? Moisture, when you say moisture control, is actually preventing water intrusions and condensations to make the building remain dry. So it's very important when you want to design a building, the building is actually must not get wet. Even if the material get wet, it makes sure it has to be able to dry very quickly. The thing is, moisture is actually involved in most of the building enclosure, and this can become a very performance issue. To mitigate that, that's where they have the concept, what we call it as moisture balance. Is the idea when you have a balance between wetting and drying, and in a way, moisture does not accumulate over time. Building is not perfect. In time, building will start to leak, they may be cracked, they may be, let's say, leak in the roof and so on. So it can cause various of problems to the building owner, to the occupants, and even to maintenance personnel. A lot of issues, staining, deteriorating of finishes, can be mold growth, can be rot, can be corrosions, and all of that will lead to high repair and maintenance. So there's a lot of way in terms for mitigation, but in these presentations, what I want to emphasize is having an insulation that will not absorb water would add added benefit to the building performance in long time durability. Okay, we talk about this water resistant, water repellent, waterproof. So what does it all means? Let's look into the terminology, the meaning behind this word. So there are these three. When we said like some material they mentions in their data sheets, in their brochure, in their website, they say that their material is water resistant, is lowest level of protection, it shed light water, but eventually will become very absorbent. Water repellent, medium range, medium of protections, is actually consists what we call it hydrophobic coatings, and that can repel water intrusion. Waterproof, highest in terms of the protection, it does not soak up water. So let's look into performance of Stonewool in water repellents. Stonewool does not absorb water. This is what you have to take in mind, does not absorb water. Reason it is because it is water repellent, it resists water absorptions. So if you actually look at the picture of the right, this picture on the right here, what you see here, when this water is in contact with the Stonewool fiber, it will form a sphere that barely touch the surface. So how do we treat this Stonewool to be water repellent? At the bottom here, it's roughly just to give an idea how Stonewool is being made. We have the stone, we go to the furnace, we melt the stone, we go through this very high spinning chamber, very high spinning RPM. And because of that viscosity of that melt, when it rotates, it will create a very small fiber. And then afterwards, it will go to the curing oven and cut to the sizes that is required. Difference with, let's say, some material, they say that water repellents, they only have the protection on the surface. Stonewool is actually the water repellent where that it add during almost the early stage of the manufacturing, where in this time, during the spinning wheel, at the same time, they will actually inject this water repellent agent or oil that causes light. It will coat every single fiber. So even that actually you tear or you ever cut the stone wool in pieces, it will and have it contact with the water, the insulation will still repel the water. Others performance is non-hygroscopic. It does not take up and retain moisture. It also vapor permeable. It allows water vapor to pass through. It's 98 porous material and have very high drying potential. Some you have this kind of misconception. Because of this porous material, it will absorb excessive amount of water. Actually, it's not. A question that you all want to ask is, all this performance that I've mentioned, can Stonewool actually be soaked in water? The thing is, when you want to design a building, you don't want that building to actually be soaked in the water, unless, let's say, you have floodings, or when there's somehow there's a poor design, there's a lack of draining ocean. But if you design it correctly, when the stone will actually in contact with water, when you have an opening, not say an area where the stone will be able to be dry, and then it able to work as per what is standard requirement. There is actually evidence, depending also on the application, that show that material will work the same even after drying out. So I talk about all these water repellents. Let's look into what are the test methods to determine this performance. In this table, you will see that there are 4 somehow associated with water. We have full emissions, we have partial, we have water repellent. Okay, some of you may confuse that some of the insulation material datasheet or brochure, they will say that in that datasheet is water vapor test. Do note that it's actually water vapor test is not a liquid test. It's actually the test to see how much vapor intake the material can take when there is a very high humidity. I will talk later about the test method. Another thing that people need to be aware is not all mineral wool are the same. Some will actually absorb excessive amount of water. So afterwards, I will just mention, I will actually tell you how does all this test is being done. Water absorption, partial emission. This is what we declare in our data sheets. It's set into PSEN 29767. Very, very simple standard, but high standards. So what you see here in the picture in the right, insulation is actually soaked in the water, 10 mm of that thickness for 24 hours. That's very, very long, because I don't think there's like, maybe there is like a radar, like say for 24 hours. And afterwards, they will check the weight before and after. And you will see that in datasheet, what we do declaration in under kg per meter square. So how much is actually within the compliant? So we look into this PSEN 13167, which is standard specification for thermal insulations, and usually the European, they will use these standards. That was stated that the partial immersion water should not be more than 1 kg per meter square for square meter. Okay, that is about partial. Let's talk about full immersions. Cover under PS 2972. Similar, almost similar, but for this test, what you do, it fully immerse the insulations for 2 hours, and then they will check the differences of weight in volume. Okay, the first one in kg per meter square, this one in volume. The third, we also do a lot of other tests, not just 1 or 2, just to make sure the water repellent performance. This is actually GBT 10299, which is test method for hydrophobic nature of thermal insulations. How we do the test is, you have the sample, 45 degrees, you just run the water at 1 liter per minute for 60 minutes. And after that, you check the weight before and after. The fourth one that I mentioned, vapor absorption test, depending, this is one which is SMC 1104, C1104M. How you do the test is, look at picture here on the right, sample, put there in the oven, heat up to 49 degrees C at 95 RH percentage. which is very, very high for 96 hours. So you want to actually see that if that insulation will absorb this high humidity. And from there, they check the weight either in percentage or they even look in volume percentage. In terms of requirements, SMC 665, which is specification for mineral wool for light frame constructions, manufactured housing, it stated that it should not be more than 5% by weight. So talking of the test method, so we want to see what are the differences of the performance of different mineral insulation. So we subject these two different mineral insulation to a series of water absorption tests and to see which one is better as well as which one is the worst. So here are the results. What you see here, we did partial immersion test, ISO 29767. Right, this is actually there are 6 samples. 2 is Stonewool 40 kg as well as 60 kg, and Glasswool 16 kg, 24, 32, and 40 kg. We not just want to see how much the water intake after we do the test. Remember, the test is actually 24-hour immersion, but we also want to see what is the performance if we let the sample dry at room temperature, whether it become, let's say, the weight become lesser for certain duration of time. And then for this test, we actually test again the weight at 24 hours and 48 hours. You see here the y-axis is in kg per meter square, and at the same time, roughly what does kg per meter square mean is how much percentage weight increase. If you look here at Stonewool insulations for 40 kg, when we finish the test, it's around 0.17, roughly around 80% of increase. Stonewool 40 kg is around 0.12%. But at the same time, if you look at here, after 24 hours, along the duration of that 24 hours, it already starts to become dry and go back to the original weight. So as opposed to Glasswool, those especially for Glasswool that's not water repellent, it reacts very poorly even after 48 hours. First test, let's say for example, we take 16 kg Glasswool, is around increase of weight of 1,002. 24-hour dry, still very high, around 900%. 48-hour dry, still very high, it's around 550%. So what's are the limit? Here, if you look at the blue color, here is the limit. The limit based on the specification 13162 say it should not be more than 1 kg per square meter. And then this is actually I want to show is thermal imaging camera just to visualize what happened to the insulation after it get wet. So you can actually already see the difference, okay, here. So for the thermal imaging camera, there's actually like slightly purple color. So this purple color is actually showing where the temperature is colder and where the material is highly soaked with water. So what I did here is actually we take the picture 24-hour dry at room temperature as well 48-hour dry at room temperature after the test. And you can see that for Stonewools actually only the bottom is actually have this contact with water because we immerse it 10 mm, whereas for Glasswool is actually fully soaked. Okay, the purple color shows that the Glasswool is fully soaked. And if you can see here, Stonewool after 48 hours, it almost dry. So it is like all this yellow color. And the thing that you also see here, this is nominal 50 mm. The sample that we took is actually 50 mm. Due to actually the weight of the water, it caused the thickness to shrink. Okay, it caused the thickness to be reduced. So that's why you can see the difference here for this Glasswool. totally shrink. Okay, that's partial, fully immersions. Similar to partial, also I look into the differences of Glasswool and Stonewool. What are the value after the test? Similar, we did 2-hour full immersions, we test that straight away, and then we test 24 hours, and then we test 48 hours. If you can see here, Stonewool is only around 0.8% as well as 1.2%. Whereas for Glasswool, it's very, very high, which is around 53% for 16 kg, 42% after 24-hour dry, and 35% after 48-hour dry. So you can see here, let's say for those mineral wool insulation that do not have this hydrophobic performance, it will actually capture, make it very easy to absorb and water. And as mentioned in that first slide, a lot of things can be affected when the insulations absorb a lot of water. Okay, let's look into the effect of thermal conductivities. You know that insulation has very, very low thermal conductivity, around 0.033 or maybe up to 0.04. So that's where in U value for roofing or even under the UBBL or even for partitions, if you want to make sure the U value is very, very low, you need to have insulations. So we want to look into what are the effects of thermal conductivity due to moisture content. So this is actually an estimation. You look into, let's say, how much this moisture content and what are the increase of that thermal conductivity. So I base back on that test standard, and the one that you look into partial immersion test. So I take the value of that moisture content. Okay, let's say here, for example, Stonewool. It's around 3.4 kg per meter cube. Let's say previously I talked about kg per meter square. This 1 kg per meter cube, which is you need to divide by the thickness. And you can see that this is rounded up to, let's say, 2 digits. You can see that from that formula, which is, it does not increase. 3.4, which does not increase, it's around 0.04. So when you dry, it go back almost the same. Whereas for generic Glasswool, 2-hour full immersions, the moisture content is very, very high, around 250, and your conductivity will increase, which is around 0.08, which is still quite high. And let's say here, after dry 24 hours, 180 moisture content, you get 0.06. And even after 48 hours, your moisture content is 163, and you will get around 0.060 Watt/meter Kelvin. So having this number, so we want to input in the, let's say, roofing application, because the requirement by the UBBL, it need to comply with, let's say, for metal roof below than 0.4. If you look into that declared data sheet of the said insulation, you will see that it's very, very low. But then again, we not just want to look at the data sheet. We want to see that once you install it in the buildings, how, let's say, for example, there's some leakage or anything, and if that insulation absorbs water, your thermal performance will be compromised. So roughly by the estimations on that formula, you will see that Glasswool, this is data taken at after 14 hours, it will actually above the requirement for of that 0.4. So in this case, the calculation is around 0.53. So these are the differences. So another thing that when it comes to thermal performance, building system look into the overall system's performance, which is thermal transmission, which is U. Then to achieve that desirable U value, you need to get a very high R value. And in this case, R value is actually D is the thickness over lambda, which is the thermal conductivity value. You see this formula itself, you know that because lambda is constant, the one that play the part is the thickness insulation. And remember back, those thermal imaging camera, soap water, the other mineral insulation, it totally sink or totally the thickness is totally reduced, and then you cannot comply with the said R value performance. Okay, and so here what we want to highlight, I want to highlight here, performance need to be based on thickness recovery for of the nominal thickness for optimum U value performance. Okay, we did another series of tests. What we did is we actually to check what are the thickness recovery when we unroll the mineral insulation after the packaging. We actually open it from the packaging. In this case, this is an example of a blanket. Blanket is most widely used in roofing applications. Usually it comes in compressed packaging because in the way they want to, let's say, save space in the container. The thing with blankets, sometimes these compressed packagings, once it unrolled, it will not go back to the nominal thickness, which is the one that they declare in their datasheet. So in this graph, we look into this performance. This is the comparison between 40 kg and Stonewool and 60 kg Glasswool. Let's first look into the 40 kg Stonewool. What we did here is actually 4 different samples. So what we did here, straight away from the manufacturing, we take the sample. After 2 days, we open it up and we measure the thickness. So there's actually, the thickness actually follow in the specification requirement. So that is under Malaysia, we actually follow the MS1020. So we have few places for the blanket that is very long, few places they measure and they take the average thickness. So here you see that 2 days, this data is also another thing that I want to highlight. Is this data is taken 10 minutes after unroll. So after 2 days, 10 minutes unroll, and then you measure the thickness, and roughly you will know that what will be the R value. So for 2 days, around 49.3, almost same as the nominal declaration, which is rough in R value is around 1.37. This one we take from manufacturing, we keep it up for 10 days, we open it up and we measure again. Again, it's almost same to 40, which is almost near to the nominal, which is around 48. This one, 90 days, and this one is 30 days. Again, you see all this performance, all this data for Stonewool. After we unroll, it go back to the nominal thickness. As opposed to Glasswool, I do note is actually the Glasswool data that we take is randomly collected sample from the market. This is actually 16 kg. So what we did here for this sample, we open it up, we let it 10 minutes, we measure. The same sample, after 1 hour, we measure again. After 24 hours, we measure again. After 48 hours, we measure again. After 72 hours, we measure again. And after 72 hours plus 1 week, we measure again. And you will see here, even after 1 week, it does not go back to the original nominal thickness as per what you declare. And in a way, it will compromise the performance of the overall U value. Right, another test that we've done is because of the, let's say, some application for roofing, when they do not have a spacer between the metal roof and the underneath, there will be a situation where insulation will be compressed. Okay, so when you compress the insulation, again, thickness will be affected, R value will be compromised, U value will be compromised. So what we did, we sent the sample to external lab, test under STM C518, thermal conductivity performance at 20 degrees C mean. The same sample, we take that sample, we measure at nominal 50 mm, compress it at 40 mm, compress again at 30 mm, and compress again at 20 mm. So we want to see what are the K value as well as what are the R value. So you can see here, the two samples that we sent here, the first one is Stonewool 40 kg and another one is Glasswool 16 kg. You can see that K value is actually increased. We will say decrease, increase in performance, decrease in numbers. Decrease slightly, but increase or decrease slightly, but R value, because of that thickness is compressed, R value will be affected. It will become lower. So actually it's not good. You compress it. If you want to comply to that certain U value performance. For this Glasswool, because of their very low density, they are easily compressed with tests up to 20 mm thickness. As you can see here, performance of the seed insulation will decrease. So, well, this is where you want to look into the balance on why sometimes actually you want to look beyond, not look to balance, you want to look beyond. You don't just look into what are the performance declaration in the data sheet. You want to make sure that once you install that insulation in the building application, make sure it performs as per what it declared. Okay, you want that insulation to last a lifetime of that duration of the seed buildings. Okay, all right. With that, actually, and for this what you call it, for the second sections, and this for the second section, we will take like a 3-minute break. I will actually present you this very short presentations. I think I can, let me see. I click the, let me know if you cannot listen, listen this video. Hold on. Okay, that's for the video. Let's look into the well, this is the last sections. I'll talk about the Rockwool Stonewool performance. First, let's look into fire performance. Fire is actually the main thing that when designing buildings, fire safety. In fire performance, there are two performance determinants. One is what we call it as reaction to fire, where the purpose of the material is actually to limit the fire growth. Another is resistant to fire, is to prevent the spread of fire to other compartments. Reaction to fire is a product performance. It looks into combustibility, ignitability, flame spreads across the surface, heat emission, character changes such as melting and dripping. So under this reaction to fire, non-combustible material is the highest classification and best performance that a material can get. A lot of standard out there, either ASTM or either ASNZS or either PS, where in Malaysia, we actually under UBBL, they actually follow the PS standard. But then again, we want to look beyond. So for Rockwool, we are tested under EN because EN is actually a national code. It has been shared by almost all the European countries. That determines by having this EN test, you know that what are the performance of the said material for reaction to fire performance. And that EN test is EN 13501-1. You can find it in our data sheet, even in our bomba. Bomba for plain product, we does not test it to BN, we test into EN. It's a very rigorous test, and to achieve the A1, which is the highest classification, they have A1, A2, B, C, D, E, F, and non-performance determinants. To achieve the A1, it's not just test into combustibility, which is ISO 11882. It also tests into heat of emission under ISO 17016. So that requirement of A1 under heat of emission test should not, heat emission is sometimes what you call it, like say in Leamington can be like energy release for that for the said material. The values, the number, the performance under A1 should not be more than 2 megajoule per kg. So let's say, for example, a petrol itself, you know, petrol is very, very combustible. Their heat of emission is around 40 megajoule per kg. So 2 megajoule kg actually very, very low for this declaration under the UN standard. So if you look at here, our Stonewool is A1. Mineral wools, various types of mineral wool can be around A1 to A2. But then again, foam is actually combustible. Okay. If you see here, EPF, XPS around E to F, B to F is already combustible material. It's actually just measured in the way how long does it take for flash over performance. PR, B to D, and phenolic foam is B to C. So foam is actually a very combustible material. Another thing that we want to highlight in terms of fire resilience is melting point. Melting point is actually a point where material changes from solid to liquid at certain temperature. So example, let's say you put candy in your mouth, and then after a while it starts to melt. So what that melting point of the candy is when we actually put in our mouth. What you see here in the picture on the right is actually a graph that shows ISO fire curve, which is a fire curve that measures with the fire load in a buildings, either commercials or even residential, and then how are the performance of the fire at that particular time and how fast the fire will grow at that particular time. So here, the comparison for Glasswool, fiberglass, is around 650 degrees C, Stonewool at around 1002 degrees C. So this high melting point, why you need a high melting point? So when you have that high melting point, in a way that that material shape able to maintain its shape even at that high temperature. If that material able to maintain its shape at a high temperature, let's say for example there's a fire happen, it able to perform its characteristic of that fire safety in a way, let's say there's no intrusion of that particular, let's say for partitions, because that insulation maintain the integrity as well the insulations. So we want insulation that have a very high melting point temperature to maintain the performance. Okay, so we look into the comparison here. So we subject the Stonewool and Glasswool to that certain very high temperature. This is what we call that a sintering test. So you can already see the difference here. A sample, 50 mm sample of Glasswool and Stonewool, 40 kg, and Glasswool 10, 60, and 32. What we do here, we put the sample in the oven at 850 degrees C, and then we check the volume. We see that Glasswool totally shrunk around 97 to 99%, whereas Stonewool only reduced of around 30%. So what I mentioned previously, you have minimum shrinkage. You have high melting temperature, you have very low minimum shrinkage, and when there's a heat, it's able to prevent the heat transmitting to the fire on the opposite side. Another thing that I want to highlight is smoke toxicity. This is where that I don't think a lot of people actually know what are the standard requirement for smoke toxicity, because the building code does not address this smoke toxicity. But there is a standard requirement. Do note that EN 13501-1 reaction to fire performance does not look into the smoke toxicity. It does look into the visibility of the smoke. So in a way that it say that if you have no smoke, then there's no, like say, smoke toxicity. There is one standard, which is ISO 13571, life-threatening component fire. So what this ISO standard do is intended to address the consequence of human exposure to the life threat component of fire as occupant is moved when this fire happened. So why we want to look into this smoke toxicity? You know, some high concentration of smoke can create hazard to a health condition. It can make you suffocate. It can cause incapacitation. It can cause irritant to eye, to nose, to throat, and it make you very difficult to escape when the fire happens. Also in fire statistics, most people die of smoke toxicity rather than the fire itself. So how you determine this smoke toxicity? Two ways, based on the ISO 13571. First is what we call it FED, fractional effective dose. This FED is based on the asphyxiant gases. When we say asphyxiant gases, is something that causes hypoxia, meaning that there is a decrease in the oxygen supply, in a way causing the occupant can cause, let's say, lost consciousness and lead to death. While the gases is carbon monoxide, hydrogen cyanide, and etc. The formula, if you look at here, exposure dose for a toxic asphyxiant over dose causing incapacitations. Another, what they look at into FEC, which is fractional effective concentration. First is asphyxiant. This one is irritant gases. So when you say irritant, it somehow affects the ability for the occupant to escape, because it affects the sensory irritation, mouth, nose, and throat sort of thing. Sometimes it may not be little, but there's a cases if you inhale too much of these irritant gases, it will take effects afterwards, few hours afterwards. Okay, also very, very dangerous. The formulas: concentration of irritants over concentration causes incapacitations. So you see here is a graph. It's actually studies. There's a link of that study on the below. I put it on the note. What this graph show is actually it make comparison of the FED, fractional effective doses, of various insulation material, which is the Glasswool, Stonewool, as well as foam insulation. So remember, FED, asphyxia and gases, cause hypoxia, can cause very little. The gases, what they measure here: hydrogen bromide, nitrogen oxide, hydrogen chloride, hydrogen cyanide, and carbon monoxide. So here the thing: the higher the FED, the toxic the material is. So you see here, FED is in number in graph, the one that shows the error. What they look at, it look into transition of fire conditions on the x-axis, which is well ventilated, finally up to under ventilated, and F is actually non-flaming. So how much the gas admin for the said insulation material. And you can see that from the graph. Let me just put a pointer here. Foam, in this case, there are phenolic foam, expanded polystyrene, polyurethane, as well as poly. So very, very high. In that, their concentration is super high. You can see in the graph itself, especially for POR, PIR have the highest FED concentrations. Let me just put it up. Okay, the highest FED concentrations. They also actually have the highest. This two foam actually has a very high concentration of hydrogen cyanide. For your information, hydrogen cyanide is actually very, very toxic. 25 times more toxic than carbon monoxide, and the exposure actually can be very, very fatal. Okay, let's see about fire. I just want to highlight again in terms of water repellency of Stonewool insulation and Rockwool Stonewool insulations. Remember back the graph, the table that I showed when we do the test for partial or even for full immersion, it's able to dry very quickly in the mid of 24 and 48 hours. Even in the soap water, the weight is so really increases around 80%. So you can see that we declare the performance in our data sheet. Low water absorptions, less than 1 kg per meter square. We are able to repel water more than 98% and 99%. And our water vapor absorption is mean that they intake, how much the water vapor intake when there's a high humidity, very, very low, in around 0.0% of volume. One thing that I want to highlight is actually what you see here. We put there long-lasting thermal performance. Stonewool sample retain the same performance more than 55 years after installations. Is a case study done by EURIMA, which is European Manufacturing Insulations. What they did is they take a sample, mineral sample, form of breeding from the set it was installed from 1990s or 1990s, and then they measure the thermal conductivity after they take the sample, and they make the comparison when it was declared years ago. You can see that from these three samples, the performance is not differ from what it declared to what it already installed. Roof view value, UBBL requirements. These are just of the example. What's the thickness that you need to comply with that UBBL requirement? So for metal roof, you know that it will be below 0.4. So to get that below 0.4, let's say for metal roof, you need 100 mm, similar to the double skin, sorry. It's around 100 mm or so. Flat roof, concrete flat roof. Sorry, also 100 mm. Well, this actually depends. I just want to show that because actually 50 mm you already can comply with 0.6, but sometimes you need a thicker insulation to comply because it's subject to the certain mechanical requirement. Another thing is, I'm not sure whether you're familiar, is we have these soffit insulations. And what you do is you just put insulation underneath the concrete floor slab and you can already comply with a 0.6. You need 50 mm and quite easy the installation. What you need is you just need insulation pins. Let's say for one insulation 1.2 and 0.206 mm, you need 5 pins, right? You need 5, or sometimes they put it 6 pin to actually help the insulation underneath the concrete slab. And with 50 mm, already comply with that U value performance. Okay, group builder rating. GBI, what are the points that we actually can contribute to the group builder rating? So these are the performance: EE1, EE2, EQ4, EQ13, MRY, and BOP2. For lead, some of you may look into lead as well. We also comply energy performance. With EPDs, we have EPDs. I will mention that later. Acoustic performance, indirectly, you use insulations. Low emitting materials, we have CDPH tests. I will actually mention later, as well as building product disclosure and optimization, sourcing of raw material. Okay, everyone talk about emissions. There are standard test requirement to see whether your material is actually able to emit your material not able emit VOC emission and formaldehyde, because we know that this VOC emission have detrimental effect to human health. What we did is we tested this one test, what we call it CDPH, California Department of Public Health. It is a requirement under LEED. They really specifically mentioned that this CDPH that you need to test this to comply with that LEED requirement. From the test, is actually what it did, just basic idea. The air sample of that VOC and formaldehyde. The sample subjected to like 24 hours, 48 hours, 96 hours during this chamber test, and they test the emissions. And from there, you can see that they also have the evaluation of that different scenario, let's say for classroom, for private office, and even for residential. So in this case, we send the sample for the test, they're able to pass. Some of you may have concern with formaldehyde. Do note that formaldehyde, actually in a home, you can find a lot of sulfur formaldehyde. Why this formaldehyde concern also, let's say, because formaldehyde is carcinogenic, and the dangerous thing is actually colorless and also very high flammable. At home, you can also find formaldehyde. Let's say you're cooking, you have this wood burning fireplace, and you are even smoking. You also found in the furniture, wooden floor, of many other household products. Formaldehyde in Rockwool, we have very small. Why we actually have this binder to actually hold our Rockwool together. But please note that Rockwool, when installed, when you even see in the test, that does not have any significant increase in the level of formaldehyde indoor and will not have health effect to human. See here, these are the value, less than 2 microgram per meter cube. And these are the emission factor, same as the TVOC. EPDs, I think for those who are familiar with EPDs, is a type 3 under ISO 14025, highest performance declarations under environmental labeling. Is actually considered gold standard in transparency of that environmental labeling. So to get these EPDs, you need to assess by the third-party verification. It uses this methodology, what you call it LCA, life cycle analysis, to assess and to quantify. That's why you look back in the EPD report, that's actually what are your emission, what are the numbers and everything, the environmental, the resources, and energy use throughout the whole product life cycle, from extraction to the product and life. in the way, let's say, it helps to educate the customer and what's going on when we manufacture the good. For Rockwool, we declare RCA cradle to grave. What a cradle to grave mean is complete life cycle of a product. That's why we show you this simple complete life cycle of the product, and impact of environment from raw material through transporting, through manufacturing, through installation, distribution, replacement, as well end of life. Some manufacturer, they will only declare cradle to gate. This one cradle to grave, this one cradle to gate, which is just declaration from extraction of raw material to end of manufacturing process. Very, very useful, where some green building consultant, they actually use this for LEED, because these are the requirements under the LEED. Okay, all right. With that, I will show you another slide. This is also in terms of water repellent. What actually we did here, you know, all the numbers and everything, I'm not sure whether you can actually remember all this number. It's something for you to visualize the effect of that, the effect of the insulations for those that have water repellent and those that don't have water repellent. So what you see here, those that don't have water repellent, it will sunk very fast in this water tank. So let me just show you. And that's just somehow, as I mentioned, just for you to visualize. It's a 4-hour test, and you can see that the other mineral insulation totally sinks inside the water tank. Right. I think that's actually end of my presentations. If you need any further informations, you can contact Selena, which is our sales manager, as well as Andy, which is our sales manager. I put that the email as well as phone number, and you can also QR code the contact. Okay, I end my presentation. That's all. Thank you so much. Any questions?
Thank you, Azanie.
Yeah.
Now we are open for Q&A session. If you have any questions, you can raise your hands, or maybe you can just drop in the chat box. There is a button to raise your hand at the bottom of the window, and we will call your name. Then you may unmute yourself. And perhaps while we are waiting to see if there's any question, I'm not too sure if I can ask this, Azanie. It's actually quite interesting on the water absorption thing about comparison with Stonewool and mineral wool. Of course, you showed that your Stonewool, you do have like a protective film layer of film to prevent water absorption. But like for glass wool, glass is something, I mean, in our knowledge or my knowledge, it's kind of like it's supposed to be something that is not absorbing water, but it appears to be a bit more absorbing more water than a stone wool. I'm not too sure if you can give us some enlightenment on how this happened.
As I mentioned, if you actually remember that, let's say for wait, I'm the thing is with, I cannot put up a slide here. Oh, right. Okay, here. Okay. The thing with Stonewool, what makes it different is actually I'll talk about Stonewool first. What makes it is different is actually, if you just look at the process itself, we coated every single fiber. That's what we give the water repellent, as opposed to Glasswool. For these tests, they do not have that repellent, and because of the porosity of that Glasswool, when they do not have water repellent, it will absorb a lot of water. Declaration under Stonewool is actually they need to test this under standard specifications. But I'm not sure about Glasswool, because the Glasswool, what do you see that some of them, they declare only vapor absorptions, which is the moisture, the vapor intake during high humidity. Well, so that's it, I think. I hope that answers your questions.
Yeah, yes, thanks. Hold on, I think, okay, there is someone asking some question in the Facebook. It's regarding how about the insulation being compressed. Will the product achieve their performance?
Okay, what kind of performance do you want to look at for insulations? Thermals, less fire, less water, less acoustic. Okay, one by one. Fire, no effects. I mean, it's just based on that material itself, but sometimes you need that certain thickness to comply with said passive fire protections requirement. Either those hourly rating or the 1 hour, 2 hour, 3 hour, then you need to comply with that requirement thickness of that insulation. Thermal, as I mentioned throughout the slide, thickness is very important, because having that thickness, that you need that certain thickness to comply with that U value and R value. So when you compress, the thickness is not there already, then your U value and R value will be compromised. Water, well, water, as I put here in the slide, if you look at here, it actually coat every single fiber. So regardless you compress or not, it will still perform as it is. Acoustic, well, acoustic actually, there's actually tools commonly used in acoustic performance. The first one, they look into sound transmission. The second one, they look into sound absorption. So for sound transmission, it's a system requirement, and for insulation, what they look is, I forgot what's the terminology. There's this terminology where they look into, I totally forgot. Anyway, these insulations, these terminologies, well, it does not differ much, and the one thing that you really need to look at for transmission loss is actually the thickness of that insulation. Again, there are some consultants, which is acoustic consultants. What they do is they compress the insulation underneath the roof to get that absorptive, so that it would absorb when there's a rain, because rain on the metal, it will give this drumming effect, it's very, very, very noisy. So they use, let's say, for insulation, they compress it to absorb that kind of rain noise. It will like I mentioned, it will compromise the thermal insulation performance, because that thickness is required unless you have more thickness than the what U value needed, which is above below 0.4. I hope that answers your questions.
I think that's pretty much it. Even my further questions regarding to acoustic, you have already addressed that. There is also Cheryl Chow. She's asking, will the Stonewool be more environment friendly compared to Glasswool?
Okay, what you mentioned by environmental friendly, what you want to look at, recyclability, or the whole manufacturing process assessment in terms of the what are the emissions. As I mentioned at the end of the slide, I did talk about, let me just show you, we do have ETs. Okay, environment. We do have this. We make a declaration. What are the environmental effects of the whole manufacturing process? As again, I would like to highlight that this is gold standard under, which is under the environmental product declarations. But in terms of recyclability, we do pre-recycle process. Or most of our reject, which actually we go back to the manufacturing process to go again through the to the manufacturing process. Please note that we does not do post manufacturing, but in some of our Rockwool in other countries, especially some of the places in Europe, they do post recycle. Another thing is, let's say, if your Rockwool in a very good conditions, you may want able to actually reuse it, and that also contribute to, let's say, one of the GPI rating requirements. I hope that answered.
I think on the recyclability and end of life, it's quite clear. Just to top up to that, how about the impact? Let's say during construction, sometimes there's bits and pieces where they just throw away.
You just treat it as a normal waste. It's not a special waste. Normal construction waste. Yeah. It does not have special treatment or some sort.
All right. If there's any more.
Any questions? No.
So far, none from. No more questions.
Okay, all right.
Or it could be sometimes a bit too technical for architects to be honest.
What I want to address in this presentation is we really want to highlight to the hydrophobic performance of the Stonewool insulations, to see that, you know, sometimes even though it's not what is specified under the certain building specifications, we want to look beyond. We want to look into building durability itself, make sure that it performs as per what it declared, make sure it's still there through the lifetime of the said buildings.
Yeah, it's a very enlightening topic. We may not realize in most situations.
Yeah, and in industrial, just to note, even though the building specification does not go into this, but industrial is very important. This is where in the projects, when they want to classify mineral wool insulation, stone wool insulation, they do mention that you need to have very low water absorption value. Why? Because corrosions is a very one of the thing, corrosion, and we call it corrosion under insulations. One of the main problem in industrial application. That's why this water repellent performance is very important. Just for information.
Thank you very much, Azanie.